In my previous video of irrational numbers, we discussed everything about irrational numbers and learned that the non-terminating and non-recurring decimal representations are come under the category of irrational numbers. Now the remaining decimal representations is clear that they come under the category of rational numbers. Like if we divide the decimal representations, the terminating one come under the category of rational numbers and non-terminating are divided into two parts. First one is recurring decimal representations and another one is non-recurring decimal representations. So I explained in the last video that non-terminating and non-recurring comes under the category of irrational numbers. It means terminating and non-terminating recurring comes under the category of rational numbers. Fine. Now we are extending our study from the last video of explaining irrational numbers to this lecture. In this lecture we are going to convert this terminating decimals and non-terminating recurring decimals in the form of p by q. Like if the decimal is terminating, it means that I have taken that example of 9 by 2. It means it is 4.5. Now you have studied that how to convert 4.5 in the form of p by q. Simply by dividing, if there is one digit after decimal, so we will multiply by 10 in numerator and denominator. We can simply get rid of the decimal. Now if I'll divide it by 5, I'll again get 9 upon 2. So I got it back in the form of p by q. So it is very easy to convert terminating decimal representations in the form of p by q, and it shows again that terminating decimal representations are rational numbers. Now we are extending our study to converting of non-terminating recurring numbers into the form of p by q. Like non-terminating recurring are, for example, I am taking convert 0.333 ... in the form of p upon q. Now how we are going to convert this in the form of p by q? See, the solution is like this. Let us assume that x is equal to 0.333 ... or I will simply write it 0.3 bar, which indicates that 3 is coming indefinite times to infinity. Now the next step is that we have to shift as many number of digits which are repeating again and again to the left side. Like 3 is repeating again and again to infinity. So what we have to do, we have to shift 3 to left side. And how will we do it? By multiplying 10. As I have to shift only a single digit to the left side, so I have to multiply by 10. So we will multiply by 10 on both sides. Multiplying by 10 on both sides. So I'll get 10x equal to 3. Now as there are infinite number of 3 in the right side, so there will be no deficiency of 3 again, so 3 will appear again here. Now consider this as equation 1 and this as equation 2. Now if I'll see here that after decimal here is 3 bar and here also 3 bar. There is infinite stream of 3 is here after the decimal, and same here also. So if I subtract this equation from this one, the digits after decimal are going to vanish because the digits are same. So subtracting equation 1 from 2. So what we are going to get is, in RHS we have to subtract the first equation from second. So we'll write 10x minus x is equal to 3.3 bar minus 0.3 bar. Now after decimal digits are going to cancel as they are same. So 3.3 bar minus 0.3 bar is equal to 3. 10x minus x is equal to 9x. X equal to 3 by 9. So answer is 1 upon 3. I mean to say that if 0.33 is in decimal form and we have to convert it in the form of p by q, so it is in the rational form of the 0.33333, and hence it signifies that non-terminating recurring decimal representations are also come under the category of rational number. Now let us take one more example of converting of non-terminating recurring decimal into the form of p by q. Now let us take 0.272727. Now in this question we have stepped up to 2 digits. Earlier there was 1 digit repeating. Now here a stream of 27 is repeating itself for infinite number of times. Now what we have to do here, go with the same procedure. Let us assume again that x is equal to 0.27 bar, and I am using bar on 2 and 7 both, as both the digits are repeating again and again. Now in this case 2 digits are repeating, so we have to shift 2 digits. Those 2 digits are repeating to the left side. Now if I have to shift 2 digits to the left side, so in that case we have to multiply by 100, because the number of digits are 2. So we need 20 number is required to shift it to the left side, and 2 zeros are there in 100. So we have to multiply by 100. Multiplying by 100 on both sides. So it will become 100x equal to 27, and as there are infinite number of series of 272727 is there in the right side of the decimal, so there will be no deficiency of 27 here. If I'm shifting 27 to the left side, then again a stream of 27 will come here. Now as we did in the previous question, so this is equation 1, this is equation 2. Now we'll subtract again equation 1 from equation 2 in order to solve the question. So subtracting equation 1 from 2 again. So what we'll do here, 100x minus x is equal to 27 minus 27 factorial minus 0.27 factorial. Now in that case what I'm going to do here is, the digits after the decimal are again same, so we are going to get 0 after the decimal. So here it is 99x equal to 27.000. So I am writing it only 27. So it will become 27 upon 99, and if I'll divide it by 3, it will become 9 upon 33, and it can again be divided by 3, so it will become 3 upon 11. So x is equal to 3 by 11. Now you can clearly see that x was equal to 0.27 bar, and now the x is equal to 3 by 11. So we can conclude here that 3 by 11 is the p by q equivalent of 0.27 bar. Understood? Now we'll go with one more example, and now you will become expertise in this topic. And the next part is, it is 0.235. Now here in this question, see here clearly, the bar is on 3 and 5, 2 is not repeating here. So there we have to adopt some different approach from the previous two questions, because there was not any digit in the right side of the decimal which was not repeating. There is a single digit which is not repeating, but it is there in the right side of the decimal. So what the approach is slightly different, but more or less similar to the previous one only. We have to adopt some different approach, and the thing is here. Please focus on this question. X equal to, let us assume x equal to 0.2, let us take 1 here. Why to take 0 always? 1.235. Now if I'll take 1.235, the bar is on 3, 5. Now in this case, the first method which we have to use, the first step which we have to adopt is to shift those digits which are not repeating to the left side of the decimal. Now so we have to first shift 2 to the left side, as it is not repeating, and in order to shift 2 to the left side, we have to multiply 10. We have to multiply by 10 on both sides. So multiplying by 10 on both sides, it will become 10x equal to 12.35. And as we can see that as there is no digit left in the right side which is not repeating itself again and again, so we have now our next job is to shift this 3, 5 in the left side. And how will we do it? As there are two digits, so we have to multiply by 100 on both sides. So multiply by 100 on both sides. We will get 1000x is equal to 1235.35, as there is no deficiency of 35 in the right side. Now consider this as equation 1, this as equation 2, subtract equation 1, so subtract equation 1 from equation 2, subtract equation 1 from 2, will get 1000x minus 10x equal to 1235.35 minus 12.35. Now 1000x minus 10x is 990x, and in this side if I'll subtract 12 from 1235 is 1223.0. I'm not writing that, so x will be equal to 1223 upon 990. So 1223 upon 990 is the equivalent, P by Q equivalent of 1.235 bar on 35. So these are the three questions. Now if you will practice these three questions, you can simply become a master in this topic of converting non-terminating recurring decimal representation in the form of P by Q. Now certainly in the next few days I am going to come with more conceptual videos on your mathematical topics, so stay tuned to us. So you're surely going to learn very new things in the coming days. Thank you.